Now we come to the second talk of this morning. We welcome Yungang Bao, who is professor at the Institute of Communication Technology at the Chinese Academy of Science, and there is also the deputy director of ICT. He is also a chief scientist in the Beijing Institute of Open Source Chip and a board of directors member of RISC-V. He will talk about RISC-V initiatives in China, and with a special focus on the XiangShan high-performance RISC-V processor, and another very interesting initiative, I think, as a teacher, which is one student, one chip initiative, which he founded as well. So, welcome.
Yeah. Okay. Thank you very much for the introduction. So today I'm going to talk about RISC-V in China. Especially, we are entering the era of open source chip. So my talk is about 3 parts. First, I'd like to share some of my understanding about the open source chip ecosystem. So today, actually, we are facing 3 dark clouds over the chip design area. One is Moore's law is ending, and IoT is coming, but fragmentation is also coming. And also, there's a global supply chain crisis is appearing. So how to address those dark clouds? I think we need innovation. We need innovation to conquer the dark clouds. We need a level to leverage hardware and software co-design and a domain-specific architecture. And we also need to develop agile chip design methodologies. And to build an open and shared ecosystem is extremely important for this area. But for chip design, it's notoriously a high cost. So there are the high cost of innovation for chip design. So for the left chart, we can see if we want to build a prototype for chip, probably a startup needs to raise about $20 million US. To compare with the internet startups, so the cost of innovation in chip area is much, much higher. But why internet companies, internet startups can benefit from those low cost of innovation because of open source software ecosystem. So with the support of the open source software ecosystem, so a small group, for example, like 3 to 5 engineers, can build a small mobile app prototype in just like 3 months. So that is why today there are like more than like almost 9 million mobile apps all over the world. So this is extremely, extremely, this is that is the impact of the open source ecosystem on the smartphone. But so we envision, inspired by the open source software ecosystem, we envision to build an open source chip ecosystem. This consists of open source ISAs, IPs, and SoCs, and open source like EDA tools, language. We also need agile verification and simulation, and plus the open source software. So together, we put them together into a platform, and that platform can provide more than 90% lines of codes that can be easily reusable. And then the customized design can only need like less than 10% of lines of code. So in this way, so the open source chip ecosystem can lower the barrier of chip development by saving time to market and the cost of IPs, EDA tools, and engineers. So that is our envision. So how to achieve this goal? We think there are 3 levels of OSCE, so the chip ecosystem. Typically, a chip is designed in several steps. Like we have the instruction set specification, And then we do microarchitecture design, get documents, and then we do engineering to get the RTL codes, and finally using EDA tools to get layout. So here, we think there are 3 levels of the chip ecosystem. First level is whether the instruction set open or closed, whether the design and the implementation open or closed. Level 3, whether the tools and the infrastructure are open or closed. So RISC-V actually layer the foundation of the whole open source chip ecosystem. Without RISC-V, actually, we can never reach the level 2 and the level 3. Here is a lesson, lessons from the failed, the so-called national instruction set architecture. So actually, 10 years ago, in China, there are almost all kinds of ISAs were adopted in China. So in 2012, Ministry of Industry and Information Technology proposed to merge them together into a unified one. But this proposal is appearing, but harder to reach a consensus. There are some problems which choose existing ISA or design a new one. If we choose the existing one, which one to be chosen? And who own the unified ISAs? So this problem cannot be solved, but RISC-V gives an excellent answer. RISC-V said instructions should be free. So that is totally different mindset from the instructions. With RISC-V, this mindset, actually, many Chinese companies and academia adopt this concept widely. And then let's look at the current state of RISC-V in China. Here is a partial timeline of RISC-V. Actually, the original RISC-V Chinese academia, the community, the Chinese community can touch the RISC-V around like 8 years ago in 2015, and then some scholars present work at a RISC-V workshop, and then the 6th RISC-V workshop was held in Shanghai, and in 2018, there are 2 alliances were founded, and some companies, startups were founded. In 2019, and the CAS launched a large project to promote RISC-V in China, and the RISC lab was established. 2020, we launched the One Student, One Chip initiative. And in 2011, we will see that the RISC-V Summit China was held. And also, more and more RISC-V chip are released. And in 2022, you can see that some large company, even like Tencent, joined the RISC-V community. And this year, a startup called Sophon announced the 60-core RISC-V processor. So this is a partial timeline, but according to this timeline, you can see how RISC-V evolved and promoted in China. Yeah, in terms of the number of members in RISC-V International, we'll see Europe, the EU is leading, and China is just behind the EU and the US. So how about startups in China? Actually, there are a lot of RISC-V startups in China. According to public information, we can see, so this is top 10 startups, how much money they raised. So already more than like $1 billion US. But there are even many companies, they are raising how much money raised, they are undisclosed. And whereas a lot of RISC-V CPU IP cores are widely used in China in different scenarios. So although those most of RISC-V CPU core are used in embedded scenario, but there are also high-performance RISC-V cores, RISC-V chips. So, for example, the Sofen, they announced the 60-core RISC-V core equipped with T-head, the Xuantie CPU core that can running up to 2 gigahertz. So it's available. We can just buy the motherboard suites from the Taobao. It's cost like $1,000. And also, Samsung donated 50 motherboards to the RISC-V International. And how about the software ecosystem? Several startups focusing on software, they released their software products, including like compilers, like a HPC platform, and also there are some open source operating system for RISC-V. But for open source project all over the world, so I think China has contributed quite a lot to the RISC-V ecosystem from like the Android open source project to like OpenJDK, even to some Fedora and Arch Linux and so forth. Research and education in China. So this year, the Ministry of Science and Technology and the National Science Foundation China are already inviting proposal for RISC-V related research. This is quite a change. This is a big change. Since over past years, most RISC-V related work was done kind of bottom up. But today, the Ministry of Science and Technology, the most already pay attention to RISC-V. And more universities use RISC-V for teaching. For example, there are already like textbook based on RISC-V. I will introduce the One Student, One Chip project, the initiative later. So this is also a university project. So the third part, I'd like to present the progress in building the open source chip ecosystem. So actually, when the China RISC-V Alliance was founded in 2018, we put forward a 3-step plan by 2013. So here is a Chinese plan. So I translate it into English. So step 1, provide silicon-proof open source RISC-V IP cores and SoCs. And step 2, we develop open source SoCs by open source EDA tool chips. And step 3, to build open source hardware automatically by open source EDA tools. So this is a long-term plan. We are actually along with, we are towards these goals. So next, I will introduce some progress about those projects. One is about the open source CPU core, and another is about the open source, the One Student, One Chip initiative, as well as the open source EDA tool. So first is the XiangShan project. This is an open source high-performance RISC-V core. It was launched in 2019, supported by the Chinese Academy of Sciences. And then after the first generation, since the second generation, the BOSC, the Beijing Institute of Open Source Chip, was involved, and together with the companies to build the XiangShan second generation and the third generation. So the first generation, the performance is is similar to ARM Cortex A76, and the second generation is comparative to the ARM Cortex A76. So this is the first generation. The real chip was back in January 2022, and the performance is about 7 per gigahertz running a spec CPU. The second generation, the target performance is 2 gigahertz at 14 nanometer technologies, and the spec CPU performance is about 10 points per per gigahertz. It's already a little bit higher than ARM Cortex-A76. But we have to see the power and error are still poor, much poorer than the Cortex-A76. So we did 4 levels of verification for XiangShan. The upper 2 levels, system level and the subsystem level, actually we have introduced the agile verification methodology. And at the module level, multi-level module and a single module, we still use the traditional verification process, including like the UVM and like formal methodology. So let's introduce our agile verification flow and tools. This is a traditional design and verification. This is a loop between the design and the verification. But actually, for XiangShan, we use Chisel to build the open source high-performance processor. Then, actually, the loop was broken. How to form a new loop? Actually, we built a bunch of tools and a platform we call the Agile Verification Platform. The platform, including functional verification and performance verification, we have built a set of new tools to bring up the new loop. So I like to see all are open sourced, including the XiangShan core RTL codes and also the design and the verification tools. So those work was published on last year's micro conference and also selected as the IEEE micro topics. And yeah, everyone can access the XiangShan project from GitHub. It's already like have the almost like more than 400 folks. Even yesterday, I found that the project was active 15 hours ago. And all the codes, programming, and integration, the specification and documents are open sourced. So XiangShan is already recognized and adopted by many companies. Last year, there are 2 companies using XiangShan, and one chip is already taped out. Another will be taped out next month. But this year, more and more companies, they decided to use XiangShan for different application scenarios, including like AI, video, and even server, GPU, and so forth. There's an interesting example, a startup called XiangShan. They took only 2 weeks to integrate dual XiangShan into their SoC and run on the FPGA. So this is XiangShan that run the Linux with the X window running on XiangShan, and they also some like 3D programs and 3D games can run on the XiangShan platform. And now a joint team is formed for the XiangShan version 3. It's about like 10 companies. This is target ARM, Nervous N2, and the spec CPU performance will be like 45 at 3 gigahertz. So the above is about the XiangShan project. Next, I will introduce the education initiative, education project. This is called One Student, One Chip initiative. We follow the philosophy of learning by doing to teach undergraduates to build real chips. And so in 2019, we launched the OSOC initiative. Here, the logo of the initiative. Actually, there's 4 Chinese characters, one student, one chip. And for the first term, 5 senior undergraduates participated in the project, and they completed the design of a 64 RISC-V processor in 4 months. And the chip was taped out with 110 nanometer technology, and it can run Linux and even their self-built operating system cores. This is a very, very tight, intensive development. So in 4 months, so every color represents a student. So they work together and to finish the whole project. And the chip was taped out And this is a Linux-compatible RISC-V core designed by the undergraduates. It's single issue, the 9-stage and in order, and also it can run like a Linux, even can run the Debian 11 on the FPGAs. So this is a real chip is back, and the student is finishing his thesis defense on the 2020 June 2nd. And this work was also accepted to RISC-V Global Forum 2020. And so since the first term, only 5 students from one university participated in the initiative. And then the initiative keep growing, and now it's on the 5th term, and already more than 4,000 students participate in the OSOC initiative from more than 300 universities all over China. And we have tracked how students are learning. Like for example, how many students apply for the program, and how many students are in the basic stage, and how many students are in the advanced stage, and so forth. So this is the outcome of the one term. So the GS2 layout of a chip designed by 50 students. So we actually combined the 50 CPU cores into 5 chips, so 5 dies. So this is save us a lot of money, since we only needed to tape out, do 5 tape outs for 50 students. This is a heterogeneous multi-core, really heterogeneous. And the chip was back, the chips are back, and students are testing their chips, and on the left, the right bottom is their chip can boot Linux and run some applications on the chips. So these students, actually, they are passionate with on the RISC-V community. So they are also contributors to the RISC-V certification course. They translate the course into Chinese. So here is, you can see there are volunteers to translation. And those students are from different universities. Thanks to the one student, one chip initiative, they come together to fulfill one goal. And what's next? So actually, we have developed an open source EDA tool we call IEDA, and completed 3 tape outs last year. And we want 2 with 2 using the 100 nanometer technology, and 1 is 28 technology. So the chip was surprising, works well. So, but the performance, the PPA is still kind of lower than the commercial EDA tools. But anyway, it works. And the next, we will let the students to use the open EDA tools to build their open source chips. So I think review the 3 levels of open source chip ecosystem. RISC-V actually lay out the foundation of the whole chip ecosystem, and XiangShan is actually targets the open source design and implementation, and XiangShan with IEDA actually is targeting the open source tool and infrastructure. So finally, make a summary. So RISC-V was selected as the 10th breakthrough of MIT Technology Review. It was considered as a chip design that can change everything. So now it is the best time for us to build a globally shared open source chip ecosystem. And the Chinese community has been contributing and will contribute more to the open source chip ecosystem. Advertisement. So welcome to RISC-V Summit China in August. So it's in Beijing, and this is the conference venue. And we'll even sponsor even speaker or on-site attendees are welcome. So thank you very much.
Thank you very much for these nice insights into Chinese developments. Are there any questions? Maybe I start once again with a question. So I was very impressed with your one student, one chip project, and especially impressed with the 4 months of duration for an undergraduate student to design a 64-bit processor. Yeah. What was included in this 4 months? Is it all, including all the synthesis, back-end flow and stuff like that, or was it more focused on the functional design?
Oh, okay, this is a good question. So actually, the students are focusing on the architectural design and RTL codes. And for the physical design, actually, we have another group to support the physical design. So, for example, to finish the verification and the physical level of verification, and to generate the GDS2 layout. Yeah, this is another group. So this is for first term, but then for the second term, third term, in the fourth term, there are some students that can complete the whole flow from front-end design to the back-end physical design. Yeah, there are some students, talented students, can finish the whole flow.
Well, it's quite interesting. We are currently doing a very similar initiative at the Technical University Munich. Oh, cool. There is a question here.
Doesn't work? Okay. Thanks for the great presentation. I have a question regarding the open source EDA system. So have you also looked into some existing ones like OpenRoad, yeah, and work together with them as well?
Yeah, thanks. So this is kind of different from OpenRoad. So actually, there are some. Actually, we found that OpenRoad is quite like how to say this. I think it's already used by many community and research groups. But we found that some tools are not that mature and stable. And also, we found that it's not easy to compare with some like CMYK technologies. So we decided to build a new EDA tool chain. So we actually built the 11 new tools. But everything is open sourced. This actually can access from the GitHub. So I think there are some difference between two projects, focus on different perspectives. Yeah.
There is another question, yes?
Hello, I'm a Linux kernel developer and I also make open source hardware boards, and I would love to be able to use that open source core on a board. Is there plans for, I mean, you mentioned a little bit there's some companies, but is there any plan for dev boards that you know of coming out with the open source core?
You mean development board?
Yeah, development board, yeah.
Yeah. So actually, we are not going to build products. We just build IP cores. So, but there are some other companies. They will they will produce like such kind of boards, and actually there are already some Chinese companies, startups. They are working on this. Yeah. Okay. On the other side, I think for actually the XiangShan project can be ported to like APG platform. I know a group in EPFL, they have port XiangShan to the AWS F1 and with the file sim infrastructure. And they did their research based on the XiangShan and got published on this year's ISCA. Yeah.
Great, thank you.
Okay, then let's thank you, Dr. Bao, again.